The 20th century is often remembered as a saga of progress: electricity, airplanes, vaccines, and instant communication. Science, we are told, freed us from ignorance. Yet beneath this luminous narrative lies a shadow. The same curiosity that gave us antibiotics and radios also opened the door to the end of everything. This documentary dives into that shadow. It tells the story of how the pursuit of knowledge crossed the boundary from protection to annihilation. At the turn of the 1930s, Europe was marching toward an abyss. Nazism was gaining strength and war seemed inevitable. In physics, the once indivisible atom was being dismantled. Researchers such as Ernest Rutherford identified the particles that make up the nucleus and understood that atoms had isotopes, versions of the same element with different numbers of neutrons. In 1932, James Chadwick discovered the neutron, a neutral particle that would allow heavy nuclei to be bombarded. In this climate of discovery, two German radiologists, Otto Hahn and Fritz Strassmann, bombarded uranium with neutrons and observed that the nucleus split into two smaller fragments. The process was named fission and, according to the calculations of Lise Meitner and Otto Frisch, released an enormous amount of energy. The scientific community realized that if this energy could be controlled, it might feed reactors. If unleashed uncontrollably, it could cause explosions of unimaginable power. To many scientists, this discovery was exhilarating. To governments, it was alarming. In 1938, Nazi Germany dominated much of Europe. Exiled physicists like Leo Szilard feared that Hitler's regime would be the first to turn fission into a weapon. In August 1939, Szilard drafted a letter warning Franklin D. Roosevelt of the threat. Albert Einstein signed it, lending his prestige to the warning. The letter said that an extremely powerful bomb could be built. Roosevelt responded by creating the Advisory Committee on Uranium, which met for the first time on October 21, 1939. This was the first step toward a project that would change the world. Soon after, on December 7, 1941, Japan's attack on Pearl Harbor brought the United States into World War II. With war declared, the committee concluded that a bomb could be built in time to influence the conflict. To coordinate the effort, the U.S. Army created the Manhattan Engineer District, led by General Leslie Groves. From this point forward, science would serve military strategy directly. Between 1942 and 1945, the Manhattan Engineer District became an enterprise of industrial proportions. Three main centers were built in rural areas: Oak Ridge, Tennessee, to enrich uranium; Hanford, Washington, to produce plutonium in large reactors; and Los Alamos, New Mexico, where bomb designs would be developed under the scientific leadership of J. Robert Oppenheimer. These sites were chosen for their distance from population centers and the possibility of absolute secrecy. The government used eminent domain powers to remove farmers, entire communities, and indigenous peoples from their lands, often with only 30 days to abandon their homes in the name of national security. The scale of the endeavor is hard to overstate. The U.S. Department of Energy estimates that, at its peak, the Manhattan Project employed 130,000 workers and had spent more than $2.2 billion by war's end. Historical studies suggest the total number of people who worked on the project, including subcontractors, may have reached 500,000, nearly 1% of the U.S. civilian workforce. To power the enrichment plants, Oak Ridge consumed about 1% of all electricity produced in the United States. Secret cities sprang up almost overnight. By 1945, Oak Ridge's population was roughly 75,000. Richland, the community at Hanford, had 15,000 residents, and Los Alamos housed about 6,000. There were cinemas, schools, stores, and hospitals, but there was no freedom. Fences, guards, and secrecy surrounded the communities. Many workers did not know what they were building. They performed isolated tasks in the name of a goal concealed from them. The project also reflected the inequities of its time. Although the scientific core was predominantly composed of white men, thousands of women, Hispanics, Native Americans, and African Americans performed manual or administrative labor. More than 15,000 African Americans were hired to work in the project cities but faced Jim Crow segregation. Meanwhile, indigenous communities lost ancestral lands to make way for reactors and facilities. The human sacrifice required to produce the bomb began long before its explosion. At the heart of the operation was Los Alamos. Oppenheimer, a brilliant and troubled intellectual, gathered physicists like Enrico Fermi, Richard Feynman, and Hans Bethe. They had to answer unprecedented questions: how to bring enough fissile material together to create a chain reaction, how to compress a plutonium core uniformly, how to ensure that the device exploded at precisely the right moment. For the uranium-235 device, a relatively simple gun model was developed. For plutonium, it was discovered that the gun design would not work. A symmetric implosion was necessary to compress the plutonium to a critical density. Building detonators capable of firing explosives in microseconds and calculating shock waves required advanced mathematics and relentless experimentation. There was also a real fear that a nuclear explosion might ignite the atmosphere and destroy the world. Some early calculations suggested the possibility, although they were later shown to be exaggerated. Even so, working under the shadow of annihilation gave the laboratory a somber atmosphere. Meanwhile, at Oak Ridge and Hanford, the challenge was purely industrial. Natural uranium contains only 0.7% uranium-235, the isotope that fissions easily. To produce a few kilograms of fissile material, hundreds of tons of ore and huge gaseous diffusion and electromagnetic systems were required. At Hanford, plutonium-producing reactors generated intense heat and radiation, demanding thick concrete shielding and pioneering safety procedures. The cost, more than $2 billion in 1945 dollars, was equivalent to that of the entire B-29 Superfortress bomber program. After years of work, the moment arrived to test whether the theories would work. At 5:29:45 a.m. on July 16, 1945, in the Jornada del Muerto desert of New Mexico, a plutonium device nicknamed Gadget was detonated. The blast, called the Trinity Test, produced a fireball brighter than the sun and raised a mushroom cloud visible for miles. Oppenheimer, watching the flash, later recalled a passage from the Bhagavad Gita, "Now I am become death, the destroyer of worlds." The test proved that the implosion bomb worked. A line had been crossed, the power to destroy cities was within reach. Less than a month later, bombing moved from the desert to densely populated areas. On August 6, 1945, a B-29 bomber named Enola Gay dropped the uranium bomb, Little Boy, on Hiroshima. 3 days later, on August 9, another B-29, Bockscar, dropped the plutonium bomb, Fat Man, on Nagasaki. The detonations reduced entire neighborhoods to ashes, vaporizing people near the hypocenter and igniting everything around. Estimates from the Radiation Effects Research Foundation indicate that, in the first months after the attacks, between 90,000 and 166,000 people died in Hiroshima and 60,000 to 80,000 in Nagasaki. Many victims died instantly from the blast and heat, others succumbed days or weeks later from burns and acute radiation sickness. Survivors, known as hibakusha, carried physical and psychological scars for the rest of their lives. The scale of suffering remains difficult to comprehend. The US government claimed that the bombs accelerated the end of the war and saved lives that would have been lost in an invasion of Japan. Indeed, Japan announced its surrender on August 14, 1945. However, historians continue to debate whether surrender was already imminent and whether the use of nuclear weapons was necessary. Regardless of this discussion, one conclusion is inescapable: humanity had unlocked the ability to annihilate itself in minutes. With the conflict over, another dilemma emerged: what to do with this new power. In 1946, the U.S. Congress created the Atomic Energy Commission, transferring control of nuclear technology from the military to a civilian agency. While some scientists advocated international control of atomic energy, rising tensions between the United States and the Soviet Union derailed broad agreements. The Cold War turned the bomb into an instrument of deterrence. The world divided into heavily armed blocs, each accumulating arsenals capable of destroying the planet several times over. The buildup was dizzying. Global nuclear stockpiles, which started with 2 bombs in 1945, grew over the following decades. According to data compiled by researchers at the University of Oxford, the number of nuclear warheads exceeded 60,000 in 1986. Even after reduction treaties, more than 12,000 warheads remain in the world. Only the United States and Russia possess thousands. This concentrated capacity can, in theory, kill millions directly and indirectly and even trigger catastrophic climate changes. Nuclear tests, common in the 1950s and 1960s, contaminated Pacific Islands, U.S. deserts and areas in the former Soviet Union, causing illness among indigenous communities and soldiers. The peak occurred in 1962 with 178 tests in a single year. During the Cold War, the world lived under the doctrine of mutually assured destruction. Leaders knew that a full nuclear attack would bring retaliation and the end of civilization. Crises such as the Cuban Missile Crisis in 1962 and lesser-known incidents nearly triggered nuclear arsenals by mistake. At the same time, the destructive power of warheads increased. It is estimated that in the 1980s, first strike capability could exceed 15,000 megatons, more than 1 million Hiroshima-size bombs, and destroy more than 40% of Earth's urban areas. After the Soviet Union's collapse, arsenals shrank, but the threat did not disappear. Countries such as India, Pakistan, North Korea and possibly Israel developed weapons. Proliferation remains a risk, and treaties like the Nuclear Non-Proliferation Treaty and the Test Ban Treaty try to stem the tide, not always successfully. Although the Manhattan Project's legacy is dominated by the bomb, the same fission physics was adapted for peaceful uses. Nuclear reactors produce electricity without carbon emissions, and radioactive isotopes are used in medicine for diagnostics and therapy. Yet every plant carries the heritage of the decision to turn science into a weapon. Accidents such as 3 Mile Island, Chernobyl and Fukushima revived the fear of the invisible, reminding us that controlling fission requires constant vigilance and political honesty. The civilian nuclear industry depends on fissile material and enrichment technologies similar to those of the bomb. Civilian programs can be transformed into military ones with relative ease, as demonstrated by Iraq's attempt to divert its program in the 1980s and today's concerns about Iran. This ambiguity permeates every debate about peaceful use of the atom. Can we enjoy nuclear energy without feeding the machine of destruction? The Manhattan Project was born of fear that Nazi Germany might develop the weapon first. Ironically, the Germans abandoned their plans, considering the effort too costly and slow. By war's end, only the United States had produced bombs. Yet the knowledge could not be contained. In 1949, the Soviet Union detonated its own bomb. Then came the United Kingdom, France, China and others. Pandora's box was open. More than 80 years after the discovery of fission, humanity still lives under the shadow of mushroom clouds that never went away. The number of warheads has fallen from its peak, but more than 12,000 bombs remain ready. A single detonation over a modern city would kill hundreds of thousands and could trigger global conflicts. The Hibakusha, survivors of Hiroshima and Nagasaki, have dedicated their lives to warning of the bomb's horror and calling for its abolition. Scientists who worked on the Manhattan Project, such as Oppenheimer, expressed guilt and tried to limit the weapon's use, even while being persecuted during McCarthyism. Thus we are left with the question that ends this story: did the Manhattan Project save lives by shortening the war or condemn humanity to eternal fear? The creation of a weapon capable of exterminating civilization represented a point of no return in the relationship between science and morality. It revealed both the best and worst in us, the ingenuity capable of deciphering the atom's core and the willingness to use that knowledge for mass killing. As long as bombs remain in silos and submarines, as long as the power to destroy worlds is nurtured in the name of security, the shadow of the Manhattan Project will hang over us. And the most terrifying question persists: what happens if, one day, that shadow becomes real?